The division of complex numbers is more of a simplification than division. If we look at a complex number, say 2 plus 3i, and divide it by 4 minus I, we'll call this example 1. What we're really going to do is simplify so we don't have an I within our denominator. And the way we're going to do that is introduce the word conjugate or conjugate. And what the conjugate is taking that 4 minus I and asking the question, what do we multiply it by to remove that I in our denominator? And the answer to the conjugate of 4 minus I would be 4 plus I. Why did I choose that? Well, if we look at multiplying 4 minus I to 4 plus I, we should see that we're multiplying two binomials, and it's the difference of each of the quantities. Remembering we have the negative I, we have a positive I, so that middle term will cancel when we multiply. Also, we can remember that I times I gives us I squared, which is simply negative 1. So that's why I choose 4 plus I. And what we're going to do is we're going to multiply the numerator and the denominator by that conjugate of the denominator. Why do I have to multiply the numerator? Because in order to multiply a fraction and not change the fraction, I need to multiply it by the same on both top and on bottom. So now my problem simply becomes 2 multiplication of complex numbers. So 2 plus 3i times 4 plus I. Let's look at that first. So we're going to distribute the 2, and we end up with 8 plus 2i, and we're going to distribute the 3i. So we end up with 12i plus 3i squared. We can do the denominator in a likewise manner. 4 distributed gives us 16 plus 4i, and the negative I distributed gives us minus 4i minus I squared. Now we can simplify it as we did in the past. Our two middle terms will combine on top. So we end up with 8 plus 14i. Remembering I squared equals negative 1, so we have 3 times negative 1, or minus 3. Our denominator, we have 16. The i's in this case are going to cancel, as we discussed at the top. Then minus I squared, remembering I squared is negative 1, so we have the negative of negative 1, we get a plus 1. Finally, simplifying, we have 8 minus 3 gives us 5 plus 14i divided by 17. And there's our final answer. Notice we don't have the complex number anymore, or the imaginary number, within our denominator after we've divided it out, thanks to the conjugate. Let's look at just one more example of division. It's going to work pretty much the same way. Let's give 7 minus 2i divided by 3 plus I in this case. Again, we're going to conjugate the denominator. The conjugate of 3 plus I is 3 minus I. And we're going to divide by 3, or we're going to multiply by 3 minus I over 3 minus I. So we're going to distribute the 7 minus 2i to 3 minus I. We end up with 21 minus 7i minus 6i plus 2i squared. So we distribute the 7, and then we distribute the 2i. Our denominator, we have 3 times 3 gives us the 9 minus 3i. Multiplying the I through, we end up with plus 3i minus I squared. our 21 is going to combine with this 2i squared. Remember, this is negative 2. So we get 19 minus 13i. And our denominator, the i's cancel. 9 minus I squared. Remembering I squared is negative 1 again. So we have the negative of negative 1 gives us positive 1. So we have 9 plus 1 gives us 10. And there's our final answer. And that is division of complex numbers.